Hello. Okay. Question number 2. A test has 5 questions. To pass the test, at least 3 of the questions must be answered correctly. At least 3 of the questions must be answered correctly to pass. There are 5 questions total. The probability that Mark answers a question correctly is 1/5. Let X be the number of questions that Mark answers correctly. Find the E of X. E of X is going to be the expected value, right? And when a probability distribution is not given, we know that E of X is equal to N times P, right? So they don't give us that whole little chart like they do down here. So I'm just going to do the expected value is the number of trials times the probability of your success happening. So now I've got 5 questions. The probability of getting a question right is going to be 1/5. So that's just going to be 1. So the expected value or the expected number of questions that you would get right if you just guessed is going to be 1 question right. Why is this freezing? Okay. I was so mad. I thought I was going to have to redo it. Okay. Find the probability that Mark passes the test. So the probability that Mark passes the test. Let's think about that. I have N equals 5. That's going to be the number of questions that the test has. The probability of getting a question right is going to be 1/5. And then he needs to get 3, 4, or 5 questions right to pass the test. So that's starting to look like a binomial CDF to me. So the probability that Mark gets at least 3 questions right is going to be binomial CDF. This is how you show your work for just a calculator question where it's like you're just typing it in, right? And I'm going to do it in here. I've got menu 5, 5B. The number of trials is 5. The probability of success is 1/5. The lower bound is going to be he can get 3 questions right and pass. He can get 4 questions right, and he can get 5 questions right to pass. So I'm going to type all those in, and I would get what I typed in was 5, 1/5, 3 to 5. And I ended up getting 0.05792. So we're going to round that to 3 sig figs and label what we found, which is the probability that he gets 3 or more right is going to be around 0.058. Oh, don't freeze on me. Don't freeze on me. Don't you dare. Okay. So then Bill, another guy. Ooh, Bill, let's change the color. Bill, you're maroon. Bill also takes the test. Let Y be the number of questions that Bill answers correctly. Okay. The following table is a probability distribution for Y. Okay, so if I need Y, this is what I'm looking at. So this is Bill answering questions correctly. The probability of him getting 0 correct is 0.67. The probability that he gets 1 question right is 0.05. And then the probabilities for 2, 3, 4, and 5 are all unknown. They are given in terms of A's and B's. Oh, wait, I lied. They give you 5. The probability of getting 5 questions right is 0.04. Okay. So question BI says, show that 4A plus 2B equals 0.24. Well, what's the relationship that I know about probability distributions? That is definitely going to help me match what things should equal. It's that the whole bottom row should equal up to 1. So let's go ahead and see if that's going to yield us this little show that we have to end up doing. Okay, so I'm going to do 0.67. This is quite a bit to write. All right, let's start sorting some stuff. So all the decimals are going to be here. All right, 0.67. What? 0.76. Whew. Okay. And then the A's, let's do the A's. So I've got an A here, got an A here, got an A here. Okay, so that is 2, 3, 4. That's 4 A's. And then the B, I've got 2 B's. I take away 1, I got 1 B. Then I add 1, that's going to be plus 2B. Okay. All right, we're getting there. So I'm just going to move this over. And I'm going to get 4A plus 2B is equal to 0.24. And we showed it. Cool. Let's do B double I. It says, given that the expected value of y is 1, we already know that. Find A and B. All right, cool. So if the expected value of y is given as 1, that's going to mean that this times this, plus 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 this times this is all equal to 1. And we're going to use that information to find A and B. So let's just set up a big, huge equation. This thing is being so slow today. Just let me change my color, please. Come on. Okay, so I got 0 times 0.67 plus 1 times 0.05. Okay, you're probably writing too, so I'm just going to stop talking. All right, cool. So let's see what we've got. This is a huge thing. I'm trying to think what would be easiest. Really, like just right off the bat, I see that like I have one equation here with 2 unknowns and I have a second equation here with 2 unknowns. So I'm definitely going to be just typing these into LinSolve, but I'm trying to determine if it's going to be easier for me to just kind of simplify it a little bit before I type it in or just type it all in. I think I'm going to try to simplify it a little bit and then I'll type it all in. Okay, so I'm definitely using this one and typing him in as is for one of the equations. Then the other one, okay, this ends up being 0, so that's just going to go away. And then this is going to be 0.05 plus, I'm going to distribute 2A plus 4B plus 3A minus 3B plus 8A plus 4B plus 0.2 equals 1. Okay. Yeah, it's probably just easier to just combine it a little bit. Okay. So I've got 2A, 3A, that's going to be 5A, plus 8 is going to give me 13A. Okay, so I've got 13A, and then for B I got 4B minus 3 is going to give me 1B, plus 4B is going to give me 5B, plus 5B, and then I have 0.05 plus 0.2, that's going to give me 0.25. I'm going to subtract 0.25 from both sides. And then I'm going to end up with 0.75. Okay, these are like way easier to type into my calculator now. So I'm going to do LinSolve menu 3, 2, solve a system of linear equations. I have 2 equations with 2 unknowns. I'm just going to do A and B because I feel like I got a lot of moving parts right now. I'm just going to use A's and B's. Then I know exactly who's talking about what. So I've got 4A plus 2B. Can you hear my neighbor mowing his lawn? Equals 0.24. And then I've got 13A plus 5B equals 0.75. All right, and then I'm going to hit enter. Okay, so what I would show for my work here is I would do 4A plus 2B equals 0.24. 13A plus 5B equals 0.75. And then I would do LinSolve on GDC, and I would get, I'm kind of running out of space here, A is 0.05 and B is 0.02. And that is my answer. Please allow me to select the highlighter. Okay. Okay, and then now, since I have A and I have B, I can go and put those back into the probability distribution table for Y, which was, who was Y? Bill, right? And then now I have a pretty good idea of what is happening here. So I'm just gonna put all this stuff back in up here. Okay, so if A is 0.05, let's see. I have 0.67, he remains unchanged. 0.05, he remains unchanged. I now have 0.09 here, and then I have 0.03, 0.12, and then 0.04 remains unchanged. So I just took these two values for A and B and I plugged them into those three that were unknown. Which student is more likely to pass the test? Well, what we're going to have to do here is compare Mike, right? So Mike, he was the first guy. He was the probability that was outlined up top here, right? And we found the probability that he was going to pass the test. That was the binomial CDF that we found, right? It said find the probability that Mark passes the test. Well, that ended up being this. So that's kind of our metric for comparison here, okay? So Mike's probability of passing the test is going to be, let's just write it formally, is going to be 0.05792. I'm just going to tack on the extra. Hey, okay, the video got deleted, so here we go. I have to go back. We were trying to figure out which student is more likely to pass the test. Mike, which we just found up here. And, oh, his name isn't even Mike, his name is Mark. That's okay. Hey, look, I'm sad it got deleted, but now I get to use the correct name. So let's go ahead and change this to Mark. Fun. And then this is Mark's probability of passing the test. And then let's look at Bill's probability of passing the test. So if he gets 3 or more questions correct, he passes the test. So I just add those 3 probabilities together. So 0.19. So it looks like our good friend Bill is going to pass the test. So we would say that since 0.19 is greater than 0.05792, Bill is more likely to pass the